Welcome to the February 2017 edition of AJP-Heart and Circulatory Physiology video table of contents, or From the Editor's Desk. I'm wearing red because February is Heart Month, so what better way to start this month but with a tour of what's inside AJP, Heart and Circulatory Physiology. This month we've published 3 review articles, 11 original articles, and 1 editorial focus. So let's get started. In our first review, Toral et al. Discussed the antihypertensive effects of PPAR beta and delta and their pharmacological activation, including molecular and functional mechanisms. These transcription factors are involved in a wide variety of vascular effects, including endothelial function, inflammation, and autonomic effects related to the hypertensive process. This is mandatory reading for those interested in new antihypertensive pharmacological targets. Second review, DeBuck et al. Delve into the use of the retinal microvascular network as a biomarker for a variety of diseases. The retina is a window to the brain and as such may represent abnormalities in the cerebral microvasculature. The role of retinal microvessels as a marker for neurodegenerative diseases is also reviewed. Therapeutic agents have a great impact on the cardiovascular system. In our third review, Chen et al. Discussed the use of aerobic exercise in anthracycline-induced cardiac dysfunction. The authors discussed the mechanisms and exercise modalities involved in reducing the cardiac effects of anthracyclines. Fru et al. Hypothesized that age-dependent increase in angiotensin II was dependent on the enzyme chymase in the heart. Experiments were conducted on hearts from 3-month and 24-month-old sedentary and exercise-trained rats. Cardiac angiotensin II was higher in age compared to young rats, in spite of ACE blockade and low levels of angiotensin I. Aged hearts also displayed an increase in the cardiac chymase expression as well as oxidative stress. These were all normalized by exercise training. On the other hand, aged rats showed a significant reduction in ACE2 and angiotensin 1 through 7. The authors conclude that chronic exercise normalizes age-dependent alterations via compromising chymase, angiotensin II, angiotensin receptor, and NOx actions while promoting ACE2 and angiotensin 1 through 7 mast receptor signaling. This paper has been highlighted in a recent podcast. Check it out on our website. Heaney et al. Assessed the ex vivo vascular function of the basilar artery and femoral artery in a transgenic Alzheimer's disease mouse model at different time points in disease development in order to determine cerebral amyloid angiopathy dependent and independent vessel wall pathology. They found that endothelium dependent but not smooth muscle dependent vasorelaxation was impaired in basilar and femoral arteries of 15-month-old Alzheimer's disease mice compared with age-matched wild-type or 6-month-old mice. This was accompanied by a reduced cyclic GMP and NO bioavailability. These results suggested that in this Alzheimer's disease mouse model, dysfunction of large intracranial extracerebral arteries important for perfusion is mediated by reduced NO bioavailability rather than by cerebral amyloid angiopathy. Blair Dotson et al. Studied vascular remodeling in the intrauterine growth restriction model, IUGR. They hypothesized that a high-fat diet would augment cardiovascular disease in this model in the offspring by decreased cardiac function and increased extracellular matrix remodeling in a sex-specific manner. Animals were fed a regular or high-fat diet prior to mating through postnatal day 21. IUGR was induced by uterine artery ligation at embryonic day 19.5. IUGR led to increased stiffness in carotid arteries in both sexes. Diastolic blood pressure was also increased. Vascular remodeling occurred in both sexes from animals fed a high-fat diet. Both IUGR and with regular or high-fat diet induced vascular remodeling, suggesting a specific mechanism of vascular remodeling and extracellular matrix production that can be targeted. Finally, Sanguisa et al. Investigated the mechanisms underlying the metabolic and vascular effects of glucose versus fructose intakes. Female rats were supplemented with 20% glucose or fructose for 2 months. At this time, aortic vascular function was determined. A variety of metabolic molecules were also analyzed. While caloric intake was higher in glucose-fed animals, plasma triglycerides were only increased in the fructose group, together with decreased expression of carnitine palmitoyl transferase 1A. Plasma adiponectin and PPAR-alpha were increased only in the glucose group. Insulin signaling in liver and aorta were more pronounced in the fructose group. Fructose attenuated vascular relaxation in response to an NO donor. Thank you for watching this month's edition of From the Editor's Desk. Please check out our new calls for papers and our podcasts on the AJP website. Please support your local heart association, and don't forget to send us your best work now. See you next month.